Here we have a SAT math question. Okay, let's go with the information. An equilateral triangle with side length K is inscribed into a circle. Which of the following defines the radius R in terms of K? Okay, first let me draw a circle with an equilateral triangle inscribed into it. Here I have drawn a circle with an equilateral triangle inscribed into it, and let me assume O as the center of the circle, and here let me assume the points A and B here. Now what I'm going to do is I'm going to draw a perpendicular line segment to one of the sides of the triangle from the center of the circle. That is, let me represent this point as A. So OM is perpendicular to the line segment AB. Okay, so here B is one of the sides of the triangle, and also it is a chord to the circle. Whenever I draw a perpendicular line segment from the center of the circle to a chord inside the circle, so the line segment will bisect the chord. That is, a perpendicular line segment OM, which is drawn from the center O to this chord AB, will divide the chord AB into two equal parts. Already we know that the length of each side of the triangle is K. So the length of this side is K, this side is K, this side is K, because it's an equal triangle. And the question says the length of each side is K. So the length of the side AB is K. Since the OM divides AB into two equal parts, the length of this part will be K over 2 and the length of this part will be K over 2. Okay, now let me connect the center O and the vertex B of the triangle. Now OB represents the radius of the circle. So that's what we have to find. Okay, now let me consider the interior angle, each interior angle measure of the equilateral triangle. So we know that all the three interior angles of any triangle will add up to 180 degree by angle sum property of a triangle. So here the measure of each interior angle has to be 60 degree because it's an equilateral triangle. So in any equilateral triangle, the measure of each interior angle has to be 60 degree. So here also we have 60 degree angle measure, and when an equilateral triangle is inscribed into a circle, and if you draw a line segment from the center of the circle to the vertex, the line segment OB will bisect this interior angle measure 60 degree. That means we'll divide this 60 degree angle measure over here into two parts. Then this part will be 30 degree and this part will be 30 degree. Already we know that this is a right, there is a right angle over here, it's 90 degree. And what must be the measure of this angle? It has to be 60 degree. So that these three interior angle measures will add up to 180 degree. Okay, now clearly OMB is a special right triangle. That is 30, 60, 90 special right triangle. So whenever we have 30, 60, 90 special right triangle, so the side which is opposite to the interior angle measure 30 degree is the shortest leg. So OM is the shortest leg, and usually we assume the length of the shortest leg in 30, 60, 90 special right triangle as X. The length of the next longer leg is the side of the triangle which is opposite to 60 degree interior angle measure. So MB is the next longer leg. So to get the length of this leg MB, I have to multiply the length of the shortest leg X by square root of 3. The length of the leg MB is X times square root of 3. And hypotenuse is the longest side. And to get the length of this hypotenuse OB, I have to multiply the length of the shortest leg X by 2. So 2X is the length of the side OB, I mean the hypotenuse. Okay, now our aim is to find the value of X. Once I get the value of X, it can be multiplied by 2 to get the length of OB, which represents the radius of the circle. Already we got the length of the leg MB, which is K over 2. Now we got the length of the leg MB in terms of X, that is X times square root of 3. So X times square root of 3 and K over 2, both of them represent the same stuff, that is the length of MB. So we can equate them, that is X times square root of 3 equals to K over 2. Okay, now to solve for X in this equation, I have to get rid of the square root of 3, which is multiplied by X. So for that, I multiply both sides by 1 over square root of 3. When I do so, the square root of 3 will cancel out. I am getting X on the left side. On the right side, K times 1 is K over 2 times square root of 3 is 2 square root of 3. Okay, now I got the value of X. Already we got the length of OB, that is 2X. Now in this 2X, let's plug in the value of X, that is K over 2 times square root of 3. So then we get 2 times K over 2 times square root of 3. So this 2 will cancel out. I'm getting 2X equals to K over square root of 3. Okay, now we have an irrational number in denominator. Usually when we have irrational number in denominator, we will rationalize it. So to rationalize the denominator over here, I multiply both numerator and denominator by square root of 3. Then I'm getting 2x equals to K times square root of 3 is K times K square root of 3. And when I multiply square root of 3 and square root of 3, I'm getting 3. So now I got the value of 2x, which is k times square root of 3 over 3. Actually, 2x represents what? 2x represents the radius of the circle. Therefore, the radius of the circle is k times square root of 3 over 3. So we find k times square root of 3 over 3 in option C. So the correct answer choice for this question is option C.